everyone. Yeah. Hi. Welcome to my stream. Hi. Oh my God, this is Gleb. Let's rock. Yeah. Thank you, Alex. Yeah. Today I'm going to test code interpreter. And basically, it is the new model from GPT from OpenAI, where you can not only generate code, but also run it. And it is kind of a big deal because you can also upload files here and analyze CSV right here. Yeah, so that's really cool. And I've been waiting it for a long time because they had closed beta. I don't know, since spring, I believe. And I wanted very much, but I think 2 weeks ago they rolled out this feature for all Plus users, and now I'm not that excited because it's much more cool than you are participating in something closed, you know. And when it is available to everyone, it is not that cool, you know. And that's why I'm testing. I think that's why I'm testing it only now. Since like it's been 2 weeks since the release. Yeah, and but still, it's I'm very excited about this feature. And I haven't tested it yet, not even just like this. And let's wake up now, cool. And before uploading a project from Stratascratch, which I have already picked, something called predict price. Before this, let's just try something. I don't know. Let's ask it to generate pandas data frame and plot a visualization. Yeah. Generate a pandas data frame and plot visualization. Oh, and by the way, I see that they have increased the limit of messages. So now you can do 50 messages every 3 hours. And before this, you could do only 25 messages per 3 hours. But personally, I almost never exceeded this limit, even of 25 messages per 3 hours. I remember maybe once or twice only I was out of this limit, you know. Data frame, visualization. What's wrong with visualization? Some typos. Okay. Bam. Let's see. Sure. Let's generate a pandas data frame for simplicity. Let's create a data frame with 2 columns, date and value. Okay, that's kinda a time series. We'll generate dates for 1 year, 365 days, and assign random values to each date. Okay, nice. After that, we'll plot the value over date. Okay, let's start by generating the data frame. And here you can see that code interpreter is at work. Yeah, so that's how show work. And here you can see the code that has been generated. And now, yes, actually you see the actual output after running this code. So yes, that's the feature. Now ChatGPT can generate it and then run it itself. So here is the something in Russian. No guitar, nor I don't know how to say shirma in English. Okay, so I think this is actually ban. Yes, sorry, bro. Yeah. Okay. So actually, no sorries here. Yes. So I don't like trolls. Okay. So let's see. So here is the table. Yes, an actual output of this code. Yeah, and looks great. By the way, in one of my previous streams, I tested Notable, a plugin, which actually provides you with the same functionality. But when you use this Notable plugin, you run your code on Notable application. So that's the integration between ChatGPT and Notable. But here, this is kind of native code interpreter, so you don't need some third-party application. It contains 365 rows, one for each day of the year 2023, and each day has a random value associated with it. Now let's plot the value over date. We can use a line plot for this visualization. Yes, agree, that's great. And here's actually matplotlib. Yeah. So it works pretty good. Random values over time. Yes, and you see that like actually this conversation with ChatGPT looks really nice, and you can share it. Yes, because now ChatGPT has a sharing feature that you can use to share with your colleagues, your friends, or your students, as in my case, because I'm doing education. Great. Yeah, so now this is a toy kind of dry run of the code interpreter, and from this dry run it looks really great. I love it. It does exactly what I expected it to do. Let's start to do something serious, let's actually understand the data project I have picked, because I picked it just like I picked something simple, but I did not look at it. Actually, I did not download it, and I didn't look at it. So and actually, yes, now I want to look at it and to get a first impression of this data set using ChatGPT and code interpreter. So let's do this. And actually the target variable is price. Okay, so the name of the project is prediction price. You have 7 attributes, and obviously we want you to build some initial machine learning model which predicts the prices. Okay, make some initial data analysis which will hint to some structures in the data and how attributes are connected. Yeah, and that's actually what I'm going, this is my main goal for today, to perform this data analysis. But again, I think that you also can use code interpreter for training machine learning models. Yes, that's obvious. Fit some machine learning model or models and explain briefly your choices. Okay. Show with some X validation, What does it mean? The power of your model and comment the results. This is cross-validation. Oh, I see. But actually, I've never seen it written like this, actually. Okay, cross-validation, cool. Present us the results and the steps you have taken, and also with some critical thinking and next steps. Okay, data description. The data is provided in the sample CSV file. Sample.csv file. Okay, and there is no field description here. That's strange. Yes, usually they provide you with the description of each column in the table. And here is there are some practicalities given here. Define, train, and evaluate a predictive model that takes as the input the data provided. You may want to split the data into training, testing, and validation sets, thank you, according to your discretion, like at your choice, as I understand. Do not use external data for this project. You may use any algorithm of your choice or compare multiple models. Make sure that the solution reflects your entire thought process. Make sure that, okay, it is more important that it is more important how the code is structured rather than the final metrics. And again, I've seen this before, and I completely disagree with this statement. Like, it is more important how code is structured rather than the final metrics. That's actually should be opposite. Yes, only final metrics do matter, and code doesn't matter actually. You're expected to spend no more than 4 hours working on this project. Okay, I understand this. Datasets.zip, and I will unzip it. And here is the sample CSV. And let's start from uploading it to Code Interpreter. And let's look how this functionality actually works. Plus downloads, datasets, sample CSV, open. Oh, and now I have to provide some instructions, yes, for ChatGPT to execute on this dataset. Okay, so let's provide it. The target variable is price, and let's ask for this, like for the actually let's just again perform a dry run and ask it to display first 5 rows, because it's always a good idea to check if everything works fine before like trying something more complicated. Let's try. I want to check that everything everything works. Display 5 first rows. Simple question, simple instruction. Working, and it immediately started to display it. Oh, so this is a very simple data set. Yeah, if you need further analysis or visualization of this data, please let me know. And now what it allows me to do is to just to actually chat with this visualization. We are still here. Where are you, Gleb? Sorry. Stream is going, yes. And I cannot see any problems actually. Yeah. So please, anyone, let me know if everything is okay with the stream. And actually I can check it myself. let me do it real quick. How can I do it? I can open it on my smartphone. Let me check. All good. Oh, thank you, Olga. Okay, so I will not waste time for chicken. Okay. Okay, thank you, guys. So here is the first 5 rows, and I kinda got some understanding about the data set. And let's try to like manually ask it. Yes, not just provide it with this general instruction of kinda analyze this for me. Yes, but just kinda perform the regular regular data analysis by like doing some usual steps. Oh, it's my fault, sorry. Okay, Mikhail, that's okay. So let's first let's ask how many rows is in the data set. How many rows are in the data set? And let's see how fast it works. How fast does it work? The dataset contains 10,000 rows. You see, I'm just chatting with the dataset, but actually, again, if I do it in Google Colab, for example, in Notebook, actually for me it's writing Python code as natural as chatting with as natural as typing just like simple human English texts. Let's check for collinearity. Yeah, we will check it. But let me just show that here again, it's not really like different from just chatting with your data. But here you just hold your conversation with the data using Python language, and in ChatGPT I use English. Yeah, so the difference is in the interface, and actually we have to compare these two interfaces: natural language and programming language. And it seems to me that very soon programming language will be more convenient in this kind of technical conversation, because it will give me more actually flexibility. Sorry. So just here in parallel, I will chat with this data just in the Google Colab. Import pandas spd df equals pd read csv. And here again, yes, df head len df. So I can do it really fast. Yes, how I do it. Okay, but again, I'm doing data analysis for like more than 10 years, and yes, for me it's natural. But for someone who just starting this journey, or just for someone who just want to analyze the data set, natural language will be, of course, much more convenient, because in order to have a conversation with the data in Python language, you have to know some Python. That's obvious. Okay. Next, actually, the suggestion in the chat is to check for collinearity, but this is not the first thing you want to do during your data analysis. And actually, when you are doing exploratory data analysis, EDA, you have to start with your target variable and see and look at its distribution and understand your target variable first, because your target variable kinda defined by your goal. And here we have a clear goal. We have to build a model which predicts the price. Yes, so I have to get some understanding about the price. Show me, let's ask it this way. Show me the distribution of price. So, and I expect to see a histogram. Yes, here is, and I like that. I think the ChatGPT used Seaborn. Yes, because it looks nice, and Matplotlib usually looks not nice. You know. So let's see. This is no, this is actually a standard histogram, but maybe it has imported it Matplotlib, or maybe it's just a different color scheme. That's interesting actually because yeah, so here edge color black, so it's not just a standard hist function of a pandas data frame, but it's something custom and a little bit tuned, you know. It's cool that he realizes that price is a data field. Yeah, that's cool, but it doesn't surprise me because, you know, here we provided a very clear context to the ChatGPT, so it's actually should understand what I'm asking it to do. If you here is the histogram showing the distribution of prices in the data set. Yes, and so what can we say about it? So the distribution is skewed, and we have some like big numbers here. Yes, big values, but they are rare actually. So this is kind of fat tail. The x-axis represents the price and the y-axis represents the frequency. Yes, so it also provides like a description of what is the histogram, how the histogram works. Also could be useful for like a beginner analyst. I also want to calculate, because looking at this histogram, it gives me some idea about the target variable, but I also want to get some metrics, some numbers, such as mean, median. So I can ask it to like provide me a describe. Can you run? But by the way, again, I'm thinking of this the process of analysis in pandas terms. You see, but again, if we imagine that someone not familiar with pandas trying to use this code interpreter, yes, so in this case he will not know about the describe function. Yeah, so I can ask what provide some other metrics about distribution. And I should specify it about the distribution because I meant price. Yeah, so yeah, and it understood me luckily. Mean, yeah. So actually, ChatGPT just ran. Oh no. Lol. So instead of running the describe function, ChatGPT ran these metrics one by one: mean, median, standard deviation, min, max, and also and also 2 quantiles, 25th and 75th. Okay, and result, yeah, so mean, average price, median, yes, and here, as expected, the median is lower than the mean because of the large values. Standard deviation of price, okay, minimum price 50, maximum price 5700, 20th percentile. Okay, cool. And here is some description. The mean is the average price, the median is the middle price when all are sorted. By the way, the very clear definition of median. The middle price when all are sorted. Cool. In ascending order. But yeah, actually, in case of the median, it doesn't matter in what order we have sorted it. Yeah, so it will be the same anyway. And the standard deviation measures the dispersion, yes, of the prices around the mean. The minimum and maximum price are the lowest and highest price in the dataset, respectively. The 25th, yeah. And yes, I like that it generates a report, and here is the clear like log and some story which goes on here. So yeah, it will be interesting to share this with someone if we are doing analysis. But the but as I think about it from a practical point of view, I understand that in very rarely you would be able to upload your data to ChatGPT because of privacy reason. You see, if you work with some like commercial data, you don't want to upload it to ChatGPT or anywhere. Yeah, so very often you will be limited in this. Yeah, but actually many companies uses, for example, Google Suite, like Google Docs or Google Sheets for doing their business. So I think in some cases it will not be a problem to upload your data to ChatGPT. What a big deal. Please try values. Try value outliers limit. Yeah, let's ask about outliers here. Yes, and clearly we have some outliers. We can see it when we can see it at this histogram. Yeah, and also we can understand that we have outliers because our mean and median, yes, is about like 400, and the maximum value is 5700. You see, so there are clearly some outliers, yes, in this data set. And let's actually ask the standard question about outliers. Yes, are there some outliers? And I think that it should I expected to look at price again. An outlier is a data point that differs significantly from other observations. They can arise due to variability in the data or errors. One common method to detect outliers is by using the interquartile range. And I don't like this method. I tell you right away. The IQR is the range between the first quartile and the third quartile. Any data point that falls below Q1 minus 1/2 multiplied by IQR or above and same stuff for the right side can be considered an outlier. This is actually the rules of box plot. Yes, you recognize the box plot. Remember this guy. The box plot is this guy. So this is the median. Yes, this is the first quartile. This is the third quartile. Yes, 75th. This is the interquartile range, IQR, and here is the whiskers. Yes, whiskers, box plot, box with whiskers, and this equal to 1.5 IQR. Yeah, so and outliers is objects which are lie here. Yes, out of the whisker, further than the whisker from other side. But again, my usual question is why 1.5? And we will ask ChatGPT it right now in a minute before like looking at what it working and what. So ChatGPT just calculated it manually. Yes, let's calculate and see if there are any outliers in the price column. Okay, so result. What is there are? Oh, and it calculated. It calculated the actual number. There are 253 outliers in the price column, which constitutes about 2.53% of the total number of rows, 10,000 in the dataset. And I love that it provides me with this total number, because in this context it is very, very useful, because then we are like thinking about outliers. Usually like people can think about getting rid of them. And here, in order to make decision, you have to clearly understand how many data points you want to drop. These outliers are the values that fall below or above the bounds calculated using the interquartile range method. Please note that identifying outliers highly depends on context and the understanding of the data. Yes, and this is true, and that's why I don't like interquartile range and box plot, because it's just one methodology for detecting outliers. And again, why 1.5? Why not 1.7 or I don't know 2? Yes. So again, it depends on your context. The IQR method is just one of many methods for detecting outliers. Yes. If you need further analysis or have any other questions, feel free to ask. And yes, I have some questions. Why IQR uses 1.5 IQR? And here I love that I can ask IQR uses why does RQR use 1.5 IQR? And here I love that you can not only ask questions about the data, about the data set you uploaded, but you also can ask regular questions like this. Yes, kind of philosophical question, or more general question, you better say. The interquartile range IQR is the measure of statistical dispersion, and it's calculated as the difference between, I know, the use of 1.5 times the IQR to define what is outlier is common convention. It's just a convention. And it comes from the box plot method, as I said, of graphically depicting groups of numerical data through their quartiles. The choice of 1.5 is somewhat arbitrary. Yes, again, that's what I said. So why not 1.7? But it has a practical interpretation. For a symmetric distribution like the normal distribution, approximately 99.3% of the data will lie with 1.5. And I don't understand actually what is actually practical about this number. Like, for example, if it if it was 99% round, yes, that would be practical. But what is practical about 99.3? I don't see any practicality here. Or of the first quartile and the third quartile. Therefore, data outside this range can reasonably be considered outliers. Yeah, so this is very, very arbitrary here. Yeah, so however, it's important to know that this is a rule of thumb. Means this is an heuristic. Yes, it's just a practical convention. The actual threshold can be adjusted based on the specific context and understanding of the data. In some fields, a smaller or larger multiplier may be used instead of 1.5. Yeah, Karina, thank you. Okay, so this is how it detects outlier. Yes, but and here again a side comment actually about detecting outliers. If we're speaking about exploratory data analysis, we just have to like look at this distribution and we understand that there are some outliers. Yes, and nothing wrong with having outliers actually. Yes, so this is our situation. That's it. You don't have to get rid of your outliers. They are just here. Yes, and yes, they complicate the situation, but it doesn't mean that you have to get rid of them. If you have outliers or like difficult distribution, you just have to use more metrics to understand it. Yeah, that's it. So yes, if you calculate the mean will be kind of broken because we have this large value here, and the mean goes up, as you see. Here the mean is 433, and that's because of these large values. They got the mean up, but not that much in this situation. Yeah, so this is not huge outliers. So yeah, if you have outliers, it's not a problem. By the way, and here the connected question is: do we have missing values? Do we have missing values in the data set? And what's wrong? Do, yeah. I'm just, I'm checking my grammar in order to improve it, yeah, because that's important. Gleb, I'm currently going through your probability and statistic playlist, and it's a treasure. Thank you. Keep up what you're doing. This was just my way of saying thanks. Pardon of interrupting you. Thank you. By the way, nice haircut. Welcome to the club. Cool, thanks. The dataset does not contain any missing values. Each column in the data frame has 0 missing or null values. If you have any other questions or need further analysis, feel free to ask. Thank you. Cool. Yeah, so, and missing values, yeah, this performed correctly, but I don't understand why it, so yes, I understand. So this is here, I just thought that it displayed the original data frame for some reason. Yeah, but here it calculated the number of missing values for each column, and then it displayed it. Yeah, and so it happened here that we do not have any missing values. So cool. But the side comment here, yes, for exploratory data analysis, if you have missing values, you do nothing. That's it. Same for actually outliers. If you have outliers, you do nothing. It's just your situation. That is your data. That's it. So do not invent your data by filling missing values. You can fill missing values only when you 100% sure with the value you're using to fill it. Or you can fill missing values for some goal. If you are training a machine learning model, actually, a machine learning model requires you to fill missing values. It just doesn't work with missing values. So in this case, you must fill missing values with something, and you can test different approaches, and you have an objective metrics in order to understand what works better. And this is the quality metric for your model. For example, like in this case, we are having a regression here, a regression problem. So one of possible metrics here is mean absolute error. So, and you just see if I fill my missing values with a mean, the metric, for example, is I don't know, let's say $50. If I fill it with median, my error is $40. So I increased the quality of the model, so it makes more sense to fill my missing values with a median. But when you are doing an exploratory data analysis, you have no objective criteria for filling your missing values. So don't do it. If you have missing values, just leave them alone. If you have outliers, just leave them alone and accept the situation that you have a difficult situation. Also, in case of outliers, sometimes it's a good idea to introduce some segments and divide your task into two subtasks, two sub-problems, like regular objects and objects with the high price, and you can look at them separately. It's also a good. It could also be a good idea. Okay, let's continue. So now I understand something about my target variable. I understand the distribution, and the second step in exploratory data analysis is to look at different pivot tables, to look how price breaks down according to these different variables. Let's ask him what model he'll suggest. Boost random forest regression. Yeah, we will do it. But before this, I want to ask it to perform this actually exploratory data analysis and to find some insights. And I will ask it to make a pivot table for each variable and to use a median for the price as a variable for aggregation. Okay, so let's do it. Make a pivot table for make a pivot table for each no, I will ask it this way. Make a breakdown of the price variable, use a median for aggregation, make a breakdown of the price variable, use the median for aggregation by each column. And let's see how it will do it. And because it by log. Oh, I don't like this output. Here is the median price breakdown for each column. Log 1, log 2. No, that's unacceptable. Please note that for log 2, para 1, para 2, para 3, and para 4, only a subset of the results is shown for brevity. If you need the full breakdown or have any other questions, feel free to ask. And actually, it surprises me, because for me it's so obvious that if you have like a numeric variable, that you have to introduce the bins for making a pivot table. And also for me it is also like natural that when you do a pivot table you have to include count, because count is a required part of any pivot table, because without a count for each category you cannot understand the confidence that you have about the numbers you see. Yeah, so that's strange. Actually, I should teach ChatGPT some data analysis. Let's make a breakdown for each variable, use median for aggregation of the price variable by each column. Let's edit. Okay, let's ask it one more time. Make a breakdown of the price variable, use median for aggregation by each column. Create bins when you do a breakdown by a numeric variable. Include counts. Include counts for each category into the pivot table. Display them as tables, because again I don't like why it decided to display this data in text format. It just doesn't make sense, because this should be a table. It's very stupid to display this data in format like this. It is just unreadable. Display them as tables, not simple text. Let's see. So now the task is more complicated, but it is quite fast. Log by log 2. So actually here, what can we see? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ST. That's some kind of strange. That's these two values looks like errors actually. Log 2. Yeah, here we have and again it displays only the small portion of this pivot table. Yeah, so if you because if you try to sum up these counts, you will not get 10,000. Yeah, and again here it should have introduced bins as I asked, but I think maybe because I see these two zeros, I understand that this column actually has a string data type, and ChatGPT did not recognize it as a numeric one, so it did not introduce any bins here. By pair 1 only the first 5 rows. Yeah. By the day of week. Yeah, here's everything fine, and we see that like right away I can see some seasonality, because on the weekend we have increased prices, but here is the counts. Here are the counts, and counts are low, so we cannot trust this data. This is just a noise. Okay, some like human analysis along the way. Okay, here only only first 5 rows are shown. Oh, and here it actually created bins as I asked. And let's see let's see how did it do it. Yeah, just by using cut. Yeah, that's fine. But here it confuse. Yeah, here by 5 bins. Bins only the 5 first rows are shown, but this is confusing because actually this is the whole table, and it's stupid to include this comment. Same here. Yeah, so here is the bins, and here we see for the variable para 3 we have an increasing trend. You see that if para 3 goes up, price also goes up. Here we have some non-linear pattern. So at first price is small, then it goes up, goes up, goes up. Oh no, it just goes up all the way, because I just for some reason I thought that it is 134 and here is 1340. Yeah, so here is the same trend. When para 2 goes up, price also goes up. So we actually discovered some insights. Here is also beans, yeah, and now now ChatGPT did a decent job actually by making these pivot tables. Here is what trend is here. Same trend. The price goes up with the para 4. Yeah, and we now can understand that there are a lot of there are a lot of correlated features, like test one asked in the beginning of the stream. But again, multi-collinearity is not a problem. It's the problem only for the linear regression, yes, and not for advanced algorithms like gradient boosting. Yeah. So actually, if you are going to use gradient boosting or some other tree algorithm, you don't have to worry about correlated features. Yeah, and by the way, there are a lot of misunderstanding around this multi-collinearity problem. And the simple way to get an intuition about this multi-collinearity, actually, what does it mean? What does it mean then two features are correlated? It means that they have a linear relationship. And from models point of view, when we're speaking about machine learning model, these two features are just the same. And so it kind of doesn't make sense to use two similar features. By using two similar features, you kind of achieve nothing. See? And this is why we get rid of similar features for linear regression. And linear regression can have problems with similar features, because a linear regression wants to assign a coefficient for each feature. But if you have two similar features, yes, what coefficients should they have? Yes, linear regression here can go crazy. So that's why we get rid of these similar features. But in the case of more advanced algorithms, you can just forget about this analysis. So here is the problem. We analyzed like these four variables, but for log 1 and log 2, this is no good. This actually, I think this table includes everything. It has, okay, but here also, to understand the trend, we should plot it. And let's ask it real quick. Please make a visualization for a pivot table with log 1. And actually, for the pivot table with log 1. And this is an example when you actually need visualization, because the table is quite big and you cannot comprehend it right away. You cannot understand it. It's very difficult to understand a trend by just looking at this table. And visualization here will be very helpful. It will allow you to get the pattern immediately. Let me demonstrate it to you. And it is interesting. Yeah. So by the way, it's quite hard to get such a visualization manually when you are performing data analysis this old school way. Yeah. So, and let's look at the code. So it's like how many lines? More than 10 lines. And I'm actually usually too lazy to write that many lines. I just usually plot the median and that's it. And my table, if I want to understand like the number, the counts for each category, I just scroll up to the table and see. So what is the trend here? And the answer actually, there is no trend. Like the median price is quite similar through all the possible values in log1 variable. Yeah, so this I think is a useless variable, should be useless variable. Yes, and here we have some like some increase, but again the counts here is ridiculous. They are just like 1, yes, or how many? 1, yeah. And the only problem we have now with data analysis is this log2 column. And I don't understand why it displayed only 5 rows. Yeah, so what's the problem with this log2 column? Let's ask, can you convert log2 column to numeric type and introduce beans, and then make a pivot table. Table I asked you. Let's see. So, and again, as I understand, this column has some string values. Please note that some values in log2 were not numeric. Yeah, like S6 and TS. So they were set as none. Yes, great. And that's funny because like if we have, oh, I see, that's just the exceeding so this is strange category. This is why the last bin O has a count of 0 and the non-median price. So, but how can it be 0? It should be at least 2 because ChatGPT found 2 distinct not numeric values. But okay, let's forget about them. So what's the trend here? And again, here it seems like there is no there is almost no trend, but you can see a slight decrease to the end. And you see this data set. It seems that this data set has been artificially broken, kinda. So they have added this like these error values into 2 columns, into log1 and log2 columns. So again, before running machine learning algorithm, we have to get rid of these values. That's obvious. So okay, let's ask him. So test one. Now we can proceed with your question. Actually, yes, I'm happy with how code interpreter performs. It's quite good and very comfortable to work with it. And it is much faster than Notable integration. And this is understandable, you know, because this is a native, like a native feature of ChatGPT, and it works much faster. But the question again, like, what is the maximum? What is like, how large a data set could you analyze here? Yes, so there definitely some limits, so you cannot upload gigabytes of data there, I think. Yeah, but for education and for some like small projects, it could be very helpful. Let's actually fit some ML models and explain briefly your choices. And now let's let ChatGPT make all decisions. Yes, just provide. I will just provide it with this instruction, very general. Fit some machine learning models and explain briefly your choices. Ask him to remove the data errors. Yes, I could do it, but I purposefully did not do it because I want to see how it will manage this situation. Before fitting a machine learning model, it's necessary to understand the type of problem we are dealing with. From the dataset and the discussions so far, and I like that it can analyze the whole conversation before running the machine learning, it appears we have a regression problem, yeah, where we are trying to predict the price based on other features. Yes, you are correct. Here are some commonly used machine learning models for regression tasks: linear regression, decision tree regression, random forest regression, gradient boosting regression. Yes, and we will not read the description about these algorithms. Given the size and nature of your data set, I would suggest starting with random forest model. Interesting. Why? Random forests are generally a good first choice for regression problems because they can handle a mix of numerical and categorical features. They don't require feature scaling, yes. They can capture non-linear relationship, yes, and interactions. And they are relatively robust for outliers and overfitting. This is true because with increasing, when we increase the number of trees in the forest, random forest does not overfit. Let's start by pre-processing the data for the model, and then we'll fit a random forest regressor. For simplicity, we'll only use the numerical features: para 1, para 2, para 3, para 4. Okay, but again, actually, log 1 and log 2 are also numerical features, yes, and from the conversation so far, as you said, ChatGPT, you should have recognized this, yes. Okay, and the categorical feature log 1 and the categorical feature log 1, yes, log 2 feature will be excluded because it has many unique categories and some of them are not numeric, yes. The DOW feature will be excluded for simplicity, but you could convert it to numerical form with one-hot encoding, yes, and include it in the model for a more thorough analysis. No, it's also important split data. Yes, the root mean square error. Yeah, so wow, and I like that it provides a report, and you can look at the actual code only if you are interested in the code. Yes, but here is just the root mean square error, and I understand. Oh, cool. So the error, this error is about $176. But again, this is not intuitive. Again, the metric itself, the root mean square error, is not intuitive. And for understanding how bad is this error, I also need to understand the mean, to keep the mean in mind. Yeah, so how off I am from the mean. And I remember that mean was about 400. Yeah, so this error is actually quite big. It's about 50%. Yeah, and the next run I will ask it to use mean absolute error and even better, mean average percentage error, MAPE. Let's look at the code and just check it. Features, okay. Target price, XY. Label encoder, log, label encoder. Y. We can use, I think, label encoder because this variable is just increasing numbers, log 1. But again, this is strange. Okay, now we split into train and test. Then it fits the random forest regressor with default parameters and number of trees equals to 100, and then just predicts. What is this? Setting with copy warning. Oh, this just a this just a lol. Try using. So this is a very kind of rookie mistake, you know. That's all beginners have this warning. This happens when you did not properly copy, when you do not properly copy your data set. Yeah. Result. The root mean square error, commonly used. This is a starting point. Okay. Some possible next steps to improve the model could be. Yeah. How about feature engineering? Yeah. Before feature engineering, let's ask it to fix this model and to add and to use all variables. First, in log 2 and log 1 and log 2, get rid of not numeric. I'm like a boss here, you know, and we can imagine that this is my employer, and my employer has sent to me his report, and now I have some comment. Yes, and this is my comment. Actually, you can imagine that this is an email from my employee, and now I'm answering. This is my answer as a boss. In log 1 and log 2, get rid of not numeric values and convert them to numeric type. Second, and and I think it should understand that if we convert it to numeric type, we should not, we don't have to use any pre-processing like label encoding or something like this. Use add DOW variable one hot you use like this, use one hot encoding for DOW variable and include it in the model. Use map for the final metric. It is much more intuitive. And here, and better do it fast, or I will fire you. Yeah. Let's see. Read or read? Read, I mean, get rid of, means then you are want to remove something. Means throw them out. Finish working. Quite fast. It appears that an error occurred during the model fitting process because the log1 and log2 columns contain non-values. Errors, chaos. Yeah, but just it didn't understand me. Actually, here get rid of non-numeric values, and it replaced it with non-values. Features. Oh, it introduced pipelines. Wow. Model pipeline preprocessor random forest. Yeah. Oh, but oh wow. It appears that an error occurred during the model fitting process because of the log1 and log2 columns contain non-values. These non-values were introduced when we converted non-numeric values to none. Yes, most machine learning forests cannot handle, and we need to apply some form of imputation. Of course, you. So, yeah, and here and now we have simple imputer also, and we just fill all missing values by median. That's perfect. But actually, the counts for these error values in log1 and log2 are so few that we can just get rid of them, just delete them. That's it. Okay, categorical, cool. Yeah, and that's absolutely amazing that after getting an error, ChatGPT fixed his error himself. That's absolutely cool. Wow. Map, yeah. And let's collapse this. The mean absolute percentage error map on the test set is approximately 0.25 or yes, 25.7%. That's much more intuitive now. MAPI is an intuitive metric for regression problems because it expresses the error as a percentage of the actual values. Yes. And MAP of 25.7% means that on average our predictions are about 25.7% away from the actual price. So they're kind of wiggling around the mean by 25%. Yeah. This result provides a starting point for the model's performance. As mentioned before, there is room for improvement. Yeah. And now, yes, this is let's consider this as our baseline, 25.7%. But actually, the approach for doing machine learning is wrong here, because we have to use a validation set, and we have to use a test set only in the very end of our analysis, after we have chosen the winner. Yes, so we use test set for getting an evaluation of our final model, and we use this evaluation for we use it as a forecast about the performance of our model with the new data. Yes, and we should not do experiments like this. We have to have validation, or like doing cross validation. Yeah, and let's actually ask it to do a cross validation here. Please do not use test set for evaluating a model. Use cross validation. Use cross validation for that. We will use test set for the final evaluation of the winning algorithm, like this. We use the test set of evaluation final of the we will use the test set for the final evaluation of the winning algorithm. Yes, let's just see if it can do a proper cross validation. We will use k-fold cross validation, which involves splitting the training dataset into k subsets. Yes, and then iteratively training the model k times, each time using a different subset as the validation set and the remaining data as the training set. Yes, the performance measure reported by k-fold cross validation is the average of the values computed in the loop. Yes, this approach provides a more comprehensive indication of how well the model generalized to unseen data. Of course, yes, that's what I'm talking about. And some error. One way to handle this. Oh, yeah, that's interesting. Yeah, because we have a very rare category in our data, this Sunday. Yes, so we don't have sales on weekends actually, but like when we like split the data into folds, we got into a situation where in some part for example in training part we do not have Sunday, and in validation part we have it. So, and the model broke here. Now, after performing 5-fold cross validation with the updated model, the average mean absolute percentage error is approximately 25.7. And this is not really surprising, because the data set is quite big and the distribution is not that skewed. So like by the law of large number, we automatically like get the very decent evaluation of our model, even without doing a cross validation. And let's see actually how it was performed. So simple imputer median, okay. Then and here one hot encoder, yes, and we added this option for handling unknown values, and we just ignore them. So if some unknown value, if we encounter some unknown value, we just mark it as 0. That's it. 0 for all possible columns. Crosswalk scores, yes. Scoring map, squirrel, yes. That's fine. After performing, yeah. Okay. Now ask him to improve the map value. How can we improve map on proof map? Yeah, because I don't want to help. I don't want to help it. Just to, and again to point out that you have to use cross validation only. Yeah, so improving the mean absolute percentage error of a model can be approached in several ways depending on the specifics of the data and the model. Here are some general strategies that could help. Feature engineering, handling outliers, okay. Hyperparameter tuning different models, trying different models, yes. And it did not mention cat boost. I don't like it. Ensemble methods, okay, increasing the training data transformation. Yeah, but and it just answered my question. I understand, but again, the whole context of our conversation implies that I actually want to improve it. Yes, so try. Let's do it. Try some feature engineering. This is spelling of engineering is always challenging for me. Let's copy and paste feature engineering. Let's try some feature engineering. Yeah. Let's see. Sure, let's try some feature engineering. We have several numerical features, power 1, power 2, power 3, power 4, and perhaps some polynomial features could be informative. Okay. Yeah, and this is pretty standard way, like the starting point for feature engineering. You just introduce polynomial features. That's very easy, and actually scikit-learn has a special function for it, so it's absolutely it's very simple to do, but for some reason it's stuck. Stop generating. Maybe it's running because we have cross validation now. So you see here it included in transformers. Yes, so this is our pre-processing stage. It included polynomial features. But for some reason let's ask it to continue. Yes, as usual, continue. Yeah, I think, yeah, so here is the result. 25.9. Lol, it's actually, oh, yes, we have improved. Oh no, to 26. No, we got worse. The result is slightly worse, yes. With polynomial, and we obtained earlier result, the polynomial and interactions features 25.7. So polynomial features is not a good idea in this case. And let's check. Yes, so it evaluated it using cross validation. Okay, hyperparameter tuning could be really time consuming. Yes, so we will not try it today, and let's try this. And also, yes, now I'm going to wrap it up actually. Yes, because it's like my standard stream is about 1.5 hours. We will try this handling outliers, and that's it. And today I will not I will not try to well, 1 2 3 1 2 3. I'm back. Thank you guys. Thank you for helping me. Yes, I'm using, by the way, I'm using this crisp noise cancellation, and it like stops it for some reason, like once in 3 or 4 hours it just turn off. The program crashes for some reason. Yes, and this is very unfortunate actually, because I like this crisp program very much. It cancels the noise. It does a good job in canceling the noise. So let's see how the capping was done. Def cap outliers, and then lambda xx, and here's how it, yeah, it included it into the pipeline. Some error. Yeah, so for now we did not improve. Yeah, so actually that's quite interesting, and let's continue this conversation next stream, and we will try to use a cat boost. We will try to use cat boost here and get the better score. And doing machine learning with this code interpreter is very, very convenient, because I hate to write this pipeline code, and it generates it very fast and very fine. But cat boost is special, and usually for cat boost I don't use any pipelines, and we will see how code interpreter will manage cat boost. So guys, thank you for coming. It was fun. Thank you for your questions, for your suggestions. It was very cool. See you next time. Bye bye. Thank you.